All right, in 5.2, we're going to talk about discrete random variables and how do we analyze them. Okay, so here's an example of a discrete random variable. Discrete random variable where x is equal to the APGAR score of a randomly selected baby 1 minute after birth, which you may or may not know, you took a test right after you were born, which is a test of your overall health right at birth. And it's an APGAR test, and you can make anything from a 0 to a 10 on it. And that's what this table is showing us, is the possible scores, 0 to 10, and the probability of getting those scores. You can see them, all right? Now, back to the problem. We can display this probability distribution in a histogram. Values of the variable go on the horizontal axis. See them down here? Horizontal axis right here. 0 to 10, there they are. The probabilities go on the vertical axis. Okay? There is one bar in the histogram for each value of x. The height of each bar gives the probability for the corresponding value. So you can see for 0 it was like 0.01, it barely even shows up on the histogram. And for 1 it's 0.006, it starts to show, and so on and so forth. You can get up to 5 and it has 0.02. It's right here. So look, our highest one is 0.437, right up there, okay? So that's what this one is. So notice, I want you to notice that on the vertical axis, we don't go from 0.000 all the way up to 1 because we don't need that in this distribution. What you want to do when you build the histogram is to make sure that you look at what's the highest probability. In this case, it was 0.43. So we round up and we go to 0.5, and then we scale back from there so that our histogram shows carefully what's going on. If we didn't do that, then we wouldn't really be able to see all these little teeny tiny ones because they would be very hard to graph. All right, I'll show you what I mean when we build one in a minute. So the first thing in analyzing a discrete random variable is the mean, the average. In probability, we call it the expected value of a discrete random variable. It's an average of all the possible outcomes, but it's a weighted average in which each outcome is weighed by its probability. All right, so here's what the formula does, okay? It's a long-run average over many, many repetitions of the same process, okay? To find the mean, or the expected values of x, multiply each possible value of x by its probability, and then you add the products. So what does that say, okay? So if this is the first expected value, I take x1 and multiply it by its probability, p1. Then I do the same thing with these two, x2, p2. And then with these three, and then x3 times its probability. And then I add up all those products, okay? And I keep doing that until I've gone through every single possibility. Obviously, with the score, there's more than 3 possibilities. Now, that can get really tedious, but I'm going to show you how to do that in a calculator. With the mean as our measure of center, okay, hopefully remember words like measures of center and spread, like we did in Chapter 1. Mean is our measure of center for a discrete random variable. It wouldn't surprise you that we'll use standard deviation as our measure of spread. Okay, those two go together, mean and standard deviation. Now, the standard deviation of a discrete random variable measures how much the values of a variable typically differ from the mean. Suppose that x is a discrete random variable with this probability distribution, and that mu x is the mean. Notice the symbols here. The standard deviation of x is, and look at the symbol, it's sigma x. We call that sigma x. And look at it, it's this giant square root, and it's taking each probability and subtracting the mean from it, squaring it, and then multiplying it by its probability. Each outcome subtracted from the mean, squared, then multiplied by its probability. And then we do the same thing again with this one. Notice we're subtracting the mean each time, okay? So it's a little tedious, but again, I'm going to show you how the calculator is going to crunch that number for you, all right? But this is our measure of spread. All right, let's try this. El Dorado Community College considers a student to be full-time if he or she is taking between 12 and 18 units. The tuition charge for a student is $50 per unit. Suppose we choose a full-time El Dorado Community College student at random. The probability distribution for the random variable tuition charge for the chosen student is shown here. Make a histogram of the probability distribution and describe its shape. So this is a two-part question. The first one is drawing the histogram. and then I have to describe it. We'll come back to that part in a minute. Well, let's first draw our histogram, okay? So we know we have a vertical axis and we have a horizontal axis. And along the horizontal axis is going to go our tuition cost. So I'm going to label it. And along the vertical axis is going to be the probabilities. All right, now look at where I start. I start at 600, I go to 900. So I'm going to start here at 600, and I'm going to do, there's 650, there's 700, 750, 800, 850, 900. Okay? Now, look at my probabilities. What's the highest probability here? It's a 0.3, right? That's the highest one there. So I don't really need to go any higher than 0.3. I can go, 0.35 if I wanted. All right, so that gives me an appropriate scale for my histogram. I would encourage you need to use a straight edge on yours. It's really hard to do that on a computer, but make sure your lines are straight, and this is very neat, okay? Now, for 600, it has a probability of 0.25, so I'm going to draw my bar all the way up here, like so. 650 is 0.1. 700 is 0.0 here. 750 is 0.3. 800 is 0.1. 850 is 0.05. And then 900 is 0.15. Okay. So there's my histogram. I've labeled my axis. I've made it neat. All my bars touch. Everything is clear. Now, describe the shape. All right, we did describing shapes way back in chapter 1 or 2, and we talk about symmetry. Remember, we talk about, is it left skewed, right skewed, or symmetric? And where does it peak, basically? Well, think broad strokes, guys. This is honestly fairly symmetric. It comes up and it goes down. Okay, it's not perfect, but it's fairly symmetric. So I would say that the graph is fairly symmetric with 3 peaks at 600, 750, and $900 tuition charge. That's all I got to do to describe your histogram. All right? Number 2, calculate and interpret the expected value or the mean of the tuition at El Dorado Community College. So you're going to use your calculator for this. And I would encourage you to stop the video or pause the video and write down these steps, and then I'm going to walk you through them with the calculator in a second. So pause the video, write them down, and then I'll show you the calculator. All right, so what I've done, as it says, you go to Stat and Edit, and you hit Enter, and you're going to go to the lists, okay? And in your charges, tuition charges, are going to go into L1, and that's what I put in my L1. In List 2 are the probabilities, and that's what I have there. Now, once those are in, then I follow these steps. It says I go back to Stat, Calc, and I want one variable statistics, the very first thing. And list should be L1. The frequency list, first time we've used that in the class, you're going to put in L2. And the way you do that is you hit second and number 2. That's all you have to do. And then you come down to calculate. And it's going to generate your mean and standard deviation. So mean, remember, is the X bar. So mean is right there. It's the 732.5. That is the mean tuition cost. Okay? So we're going to write that down. You would do the symbol mu t, because mu means mean and t is tuition. It's going to be 732.50. All right? Now that's the calculate part. You didn't have to do a whole lot. Just put in the calculator. Now interpret. Here's how you would interpret the mean. If many students from El Dorado Community College are randomly selected their average tuition will be about $732.50. Okay? That's how you interpret an expected value. Okay? So catch what you're always going to use. You're always going to use this phrase, if many, many something from whatever. It always has to start with if many, many, and then you put in the context of the problem. Okay? So what's specific to this problem? Students from El Dorado College. That is really specific to this problem. Our randomly selected is always going to be in your sentence. The average or their average tuition is unique to this problem, and then the value is unique to this problem. Okay? But everything else that I didn't highlight should be in your answer every time. Okay? Make yourself a note of that. Now, moving on. It says calculate and interpret the standard deviation of t. Well, if you've done the mean, you have this screen on your calculator, right? Notice the sigma that's right down there. It looks like this little O. Okay? It's this shape right here. Look for that sigma. See it right here? It's at 102.80. That is the standard deviation. Okay? So I would put sigma of t is, from the calculator, it's 102.80. Remember, we're talking dollars and cents, so you don't need 3 decimals, you just need 2. So that's the calculate part. Easy, right? Calculator did it. Now, interpreting this, standard deviation always is typically varying from the mean. That's the phrase we're going to use all the time. So when we interpret a standard deviation, here's how it's going to look. It's going to say a randomly selected student from El Dorado College has a tuition that typically varies from the mean by 102.80 cents. Okay? So, randomly selected student from El Dorado College has a tuition that typically varies from the mean by, and there's my note. Okay? Again, some of these parts of the sentence you're going to use every time you interpret standard deviation. So I'm going to highlight the pieces that are unique to this situation with El Dorado College. Okay? A randomly selected student from El Dorado College has a tuition, because that's what we're measuring. It typically varies from the mean by this. Okay, so if I didn't highlight it, you should see it in every sentence. The parts that I did in yellow is going to change problem to problem. That's the context of the problem that you have to read for and apply correctly. All right? So that's the 3 types of problems you're going to see on your homework. Hope that makes a little bit of sense to you, and we'll see you in class.